Okay, so this is a continuation of the previous video. Here we take the square root. We divide by 5 here. So then that gives us, let's see, I'm going to come here and say x squared equals 0, but then we take the square root, which means x equals 0, and this one is a double solution. For this one, subtract 2, which means x equals -2, and for this one, subtract 1, and then we have 3x equals -1, then divide by 3. So then x equals -1/3. Okay, so now let's sketch the graph. So we need, let's say this is -2, and let's say this is -1. So -1/3 will be about here. But right there again, those have to be perfect. We're guesstimating here. And this is where we have the double solution or double root. So intersection here and intersection, and this one's going to be a pain, right? Because it's too close to the origin, -1/3. Okay, so we have a positive lead coefficient, which means the right-hand behavior is up. Okay, then degrees, again, even, so then the ends go in the same direction. So left-hand behavior is also up. It goes to positive infinity. So then it's going to cut through -2 because that's a single solution. And then it's going to cut through -1/3. But then it's going to turn like this and then go back up. So it looks kind of like this. All right, so that's for number 2 and number 4. Let's go on to number 6. So for number 6, number 5 through 8, using infinity notation, describe the end behavior. Then sketch the graph of the parent function. I am not going to do this again for the sake of time, but I will sketch the graph of those functions. So let's start with number 6. Okay, so for number 6, the highest degree is the 4th degree. So that means degree is 4. And then number of turns, you to subtract 1 from the highest degree. So then that means it's going to have 3 turns. So let's start with the following part. So let's see, we'll get this once we sketch the graph. You might be able to see it without the graph. First, notice that we have a positive lead coefficient, which means the right-hand behavior is up, goes to positive infinity, okay? And we have degrees even, so then that means the right-hand behavior is also going to positive infinity. And it's got 3 turns, so it looks kind of like this. There's 1 turn here, another turn, and a third turn. So then notice that as x goes to -infinity, which is the left side, y goes to positive infinity. And as x goes to positive infinity, which is the right side of the graph, y also goes to positive infinity. Okay, so that's all for number 6. Let's go on to number 8. Okay, so for this one, this is not arranged in order. It's not in standard form, so this is the highest power. Okay, so notice that there's a negative in front of it, so then the degree, we know it's degree 3. And then number of turns, this one's going to have 2 because you have degree 3, subtract 1, so it's going to have 2 turns. Okay, so then negative lead, so that means the right-hand behavior is down. And since the degree is odd, then the left-hand behavior is up. Don't forget this. If degrees are even, same direction. If degrees are odd, then opposite directions. Okay, so this one has 2 turns, so it's going to look like this. Goes down and then turns and goes back down. Okay, so now the left-hand behavior, as x goes to the left, which is -infinity, y goes to positive infinity because this is pointing up. And as x goes to the right, which is this end here, y goes down, which means it goes to -infinity. And that is all for number 8. For number 9 through 10, okay, we need to write an equation in standard form for a polynomial that has the given zeros. So then this is y equals, let's see, this is positive 3, so that means it should be x minus 3. Instead of a parenthesis, this is minus 5, so it should be plus 5. And we have 2 of them. Okay, so I'm going to multiply these 2 first, and then I'll do this one last. So when we multiply, we end up with this. All right, so don't forget I explained this in class. X times 5 is 5x, -3 times x is -3x, so 5x minus 3x gives you 2x. -3 times 5 is -15. And x times x gives you x squared. So I'm just missing the square there. Now let's multiply by this one. So when we multiply, we end up with this. Okay, but then I have to combine like terms. So then I have x cubed plus 7x squared minus 5x minus 75. Okay, and that is by combining like terms here. Let's go on to number 12. So this is cumulative. Let me remind you of a few things here. and that is that I squared is equal to -1. Okay, so 3 times 5, I'm just going to simplify this by distributing what's in front of the parentheses. Okay, so I distribute 3 times 5 is 15, 3 times -4i, it's -12i, -i times -2 is +2i, -i times +9i, that's -9i squared. But then again, this becomes a -1, which means 9 times -1 is -9, but then we have a +15. When we combine 15 and -9, that gives us a +6, and then -12i plus 2i is -10i, and this is the answer to number 12. All right, so we know this is an exponential function. Okay, so if f of x is equal to 2 to the x plus 2 minus 1 x to the 2 to the x plus 2 power minus 1, and g of x is the inverse, state the domain of g of x using interval notation. Well, since exponential functions look like this, right, the domain is all real numbers, which means from -infinity to +infinity. The range goes from -1, that's where the asymptote, the horizontal asymptote is located. So let's say we know that the asymptote is horizontal. So then this is the range. So this becomes the domain of the inverse function, which is g of x. So then the domain of g of x is -1 to +infinity. And that is all for number 14. All right. I'm going to skip this one. You won't see it on the exam this time. Okay. Let's go to number 18. For number 18, in each of the following equations, what is the value of x? So here, what you need to do is get the square roots on both sides of the equal sign. So that's what I'm going to do. I'm going to jump this one to the other side, which means I'm going to add it. Okay, so that's what I just did here. I need to get rid of the radicals or the cube roots. So I'm going to raise both sides by the third power. Okay, so then that gives me 3 cubed is 27, and cube root of x, cube is x, and this equals x plus 2. Then I'm going to subtract x from both sides, and it gives me this. Then I'm going to divide by 26 on both sides of the equal sign, and that gives me x equals 2 over 26. That's 1 over 13. So this is the solution to that equation. Okay, let's go on to number 20. Number 20 is an exponential. So we got to take the inverse of the exponential, which is the logarithmic. The base of the exponential is 32, so then that becomes the base of the logarithmic. So this will be log base 32 of the number 4 is equal to x. Then I'm going to go to the calculator and enter this in the calculator. So to go to the calculator, press the math key, then the alpha key, then the alpha key again. The math key again, and then enter this information on the calculator. So that's what I did here. Okay, so let me do it again. So press math, alpha math, and then the base is 32. The number inside of the parentheses is the 4, and it gives you 0.4. So this is the solution to this equation. And that is all on my end for the review for this exam. Make sure you copy the examples, and then I'm going to ask you to turn this in tomorrow. Okay? All right, thank you for watching. Bye-bye.